For the second part of Lesson 9.1, some of this might be review. Depending on when your class got dismissed early from school yesterday, we didn't get through as much of the material as we did in other classes. If you've already seen the work for midpoint, you can fast forward to the perpendicular bisector section. If not, feel free to follow along from the beginning. We've talked about the distance formula, and now we'll look at the midpoint formula. And out of the two of them, typically the midpoint formula is the easiest for students to kind of navigate. You're just finding the middle of two coordinates on a coordinate system. We still need to identify x1 and y1. And the midpoint is found simply by taking the average of the x's and the average of the y's. Your answer will be an ordered pair, and the denominator will always be 2. There's no square rooting or anything to solve. Let's try the first example. Find the midpoint of the line segment joining -5, 1 and 1, 6. The first thing you want to do is plot those 2 points on the graph over on the right-hand side. Hopefully it looks something like this. And like the distance formula, you also want to use your coordinates and identify the x1, y1 location and the x2, y2 location. From here, we apply the midpoint formula. So the midpoint of those two endpoints will equal the average of the x's, so x1 plus x2 divided by 2, comma, and then the same thing with the y's, y1 plus y2 divided by 2. Simplify each fraction to find the coordinates for the midpoint. If we take -5 plus -1, that's -6. And -6 divided by 2 would reduce to -3. 1 plus 6 is 7, and 7 divided by 2 is 7/2 or 3.5. That should be the midpoint of that segment. Over at the right, if you plot -3 up 3.5, you're about right there, and that would be the midpoint of that segment, just like that. Down below, let's work backwards. Here we're asked to find the coordinates of point A if the midpoint of AB is -3, 2 and B is at point 5, -6. If we're trying to find the coordinates for point A, I'm going to identify those as my x1 and y1. The midpoint is -3, 2, so I'll label that capital M. And that means point B would have to be my other coordinate, x2, y2. Like we did yesterday with distance, the first thing I'm going to do here is just redefine the formula. Midpoint equals x1 plus x2 divided by 2, so taking the average of the x's, y1 plus y2 and divide by 2, the average of the y's. What makes this unique is we actually know the answer on the left. I'm going to substitute in -3, 2 for that answer. Now on the right, we have x1 plus x2, so x1 stays, but x2 is 5. And then we divide that by 2. That's the formula. y1 plus y2 would be y1 minus 6, or plus -6, divided by 2. This looks kind of crazy, but in order to get x1 and y1 alone, we're just going to match up the x part of the answer for the midpoint to the x part of the work. So to get x1, I'm just going to take that -3 and set it equal to x1 plus 5 divided by 2. So the left side's the answer, and the right side is the formula to get it. But to get x1 by itself now, we got to do a little about algebra. If it's x1 plus 5 divided by 2, the first thing you'd want to do is just multiply both sides by that 2 to get rid of the fraction. On the left, 2 times -3 is -6. And then on the right side, the 2's eliminate. And we have x1 plus 5. Finally, to get x1 by itself, we'll just move 5 over by subtracting. And the x1 coordinate, there's just one answer here. -6 minus 5 is -11. Can you do the same thing with the y's? Can you take the y part of the answer, set it equal to the y part of the work, and solve for the y1 coordinate? Pause the video and see if you can try that. Once you think you have it, press play and we'll see how you did. How about y1 equals 10? Did you get that? I just set 2 equal to y1 minus 6 over 2 and followed the same process I did for x1. Last but not least, you're just going to write your final answer as an ordered pair. Negative 11, comma 10 would be the coordinates for point A. The second part of 9.1 is finding the equation of a perpendicular bisector. A perpendicular bisector is a line, ray, or segment that is perpendicular to another segment at its midpoint. Now, the perpendicular bisector is the equation of a line, or that ray or segment. We have steps to find this out. For the perpendicular part, you're going to take your two ordered pairs and find the slope first. Remember, the slope formula back from chapter 2 is y2 minus y1 divided by x2 minus x1. Be sure to simplify. Then you're going to make it perpendicular. You want your new line to be perpendicular to the given segment. So we have to take the reciprocal and change the sign. And we're done with step 2. The bisector part simply means we're going to find the midpoint of the original segment. So we'll follow the formula from up above. To create the equation, we're going to go back to what we did in chapter 2. We'll use the step 2 answer for our lowercase m and the step 3 answer as our new x1, y1. And we're going to plug it into point slope form. Y minus y1 equals m times x minus x1. And again, we'll be sure to simplify. Make sure you have all these steps written out before you move on to the two examples at the right. Here we're asked to write an equation for the perpendicular bisector of the line containing the 2 points. We'll start with negative 5, 6 and 1, 8. Now, like we did for midpoint and like we did yesterday for distance, the first thing you're going to want to do is identify your coordinates to help us with our steps. The first point we'll identify as x1 and y1 for now, and then our second point, x2 and y2. Remember, we're going to start off with the perpendicular steps. In order to find something that's perpendicular to the line that contains these 2 points, we first need to calculate the slope. Now, the slope formula is y2 minus y1. That would be 8 minus 6 over x2 minus x1, 1 minus negative 5. 8 minus 6 is 2, and 1 minus negative 5, which would be 1 plus 5, is 6. And this reduces to positive 1/3. That would be the slope of the line that goes through the 2 given points. The second thing we want to do is make that perpendicular. So the perpendicular slope, the perpendicular symbol is an upside down T with a little right angle. So we'll just call that the perpendicular slope. If we take the reciprocal of 1/3, that would be 3 over 1, or 3. And if we change the sign, this one has to be negative. And that's all we do for that part. Then for the bisector part, step 3, we need to find the midpoint. So that's capital M. So sometimes it's tricky with the lowercase m for slope and capital M for midpoint. Try your best to differentiate. Here we're going to do x1 plus x2, negative 5 plus 1 over 2, and y1 plus y2 over 2. Negative 5 plus 1 is negative 4, but when you divide that by 2, you get negative 2. So negative 5 plus 1 is negative 4, divided by 2 is negative 2. And then we have 6 plus 8, which is 14, divided by 2, that gives us 7. So those are the big steps to help us write our equation. So in step 4, to write our equation, our lowercase m is from step 2, and our new x1, y1 is the midpoint, negative 2, 7. These are the values we use, and we're going to plug them into point slope form. Y minus y1 equals m times x minus x1. Substituting in what we know, y minus y1 would be y minus 7. M is negative 3 times x minus x1, x minus negative 2. Keep y minus 7 for now. Distribute the negative 3 in to get rid of the parentheses. And we have minus negative 2, so that actually became plus. If we distribute the negative 3 in, we have negative 3x, and then negative 3 times positive 2 is going to be negative 6. Last but not least, to get y by itself, I'm going to add 7 to each side. And the equation for the perpendicular bisector is this. Y equals negative 3x plus 1. That would intersect the points joined by the line or segment at negative 2, 7, and it would form a 90-degree angle. Let's try one more. The same process. Now we have points 3, 8, and 7, 14. Identify the coordinates as x1, y1, and x2, y2. I'd like you to do steps 1 and 2. Find the slope and then make it perpendicular. Then press play and we'll go on from there. Did you end up with negative 2/3 for your perpendicular slope? I did 14 minus 8, or y2 minus y1, over 7 minus 3, and simplified the fraction. From here, let's go on to midpoint, step 3. That's our capital M. y2, x1, plus x2 all over 2, and y1 plus y2 all over 2. 3 plus 7 is 10, and 10 divided by 2 is 5. 8 plus 14 is 22, divided by 2 is 11, and there's our midpoint. That's simple. Step 4 is where we write our equation. Remember, our lowercase m is our perpendicular slope, negative 2/3. Our x1, y1 is our midpoint, that's 511. And we substitute all of that into point slope form. Y minus y1 equals m times x minus x1. I'd like you to try this as well. Press play, and then we'll be done. Once I substituted in my m, x1, and y1, I got y minus 11 equals negative 2/3 times x minus 5. It gets a little tricky with the fractions, but we've dealt with fractions before, so this shouldn't be too far away from what we're used to. I kept the y minus 11, and I got negative 2/3 times x, plus when I took negative 2/3 times negative 5, I just multiplied the negative 2 and the negative 5 and got positive 10. 3 doesn't get multiplied to anything, so 3 stays in the denominator. Moving the 11 over, I added it, and I just got it a common denominator with the 3, and I made it 33/3. 10/3 plus 33/3 would be 43/3. The equation for the perpendicular bisector for this problem, y equals negative 2/3 x plus 43/3. And that's how you write the equation of a perpendicular bisector. Your assignment is just to complete the rest of the 9.1 worksheet from Tuesday. So if you didn't do the midpoint problems in 1 through 6, be sure to do those now. Also add on the rest of the problems so that you've completed 1 through 14.